This is 6.2.1.4. We will now discuss the periodic nature of CK. So in a periodic sequence x of n, when we perform the analysis CK, we know that we are asked only to find k equals to 0 to n minus 1. Why not n? N plus 1, n plus 2, and so on. And why not k equals to minus 1, minus 2, and so on? Why only do we do k equals to 0 to n minus 1? And the reason is because CK is periodic n. Okay, and why is this so? Okay, let's take a look. Now, if we are given this complex exponential and we are saying that k represents the different harmonics and k equals to 0 to n minus 1, so what happened? Well, let us now add k equals to n for whatever big N is. We'll show you that ej 2 pi over n times k and is equals to e j 2 pi over n k plus big N n. Alright, once we have shown you that this is true, then it means that this k is n periodic. So we'll dump the capital N here, and we'll now split this complex exponential into two terms, the first one and the second one, and you will realize that n can cancels and small n is integer, and if small n is integer, it means that it will be ej times 2 pi times any integer. Ej times 2 pi times any integer will give you basically cosine 2 pi times any integer plus j sine 2 pi times any integer. Now, sine of 2 pi of any integer is 0 and cosine of 2 pi is 1. So in this case, this term here reduces to 1, showing that ej 2 pi over n times kn is equals to this expression on the left. Hence, we can conclude that once we have calculated ck from 0 to n minus 1, it is the same as from n to 2n minus 1. It's the same as from minus n to minus 1. Okay, and graphically it looks like this. So once you have calculated from 0 to n minus 1, then now the terms will repeat. I will change a different color, green here. So this repeats, and this is the repeat. So you can see from 0 to n minus 1, this is from n to 2n minus 1, this is from minus n to minus 1. They are repeating patterns for CKs. Okay, now if you can see this repeating pattern, therefore C minus 1, now I use a red pen, this is C minus 1 is the same as Cn minus 1. Okay, and that is why just now in our previous example of C minus 35, sorry, C35 is equals to C minus 5. So this is the problem that we want to solve. We want to tell you that at k equals to 35, it is the same as k equals to minus 5. And this was to solve for k equals to minus 5. So with that, that concludes 6.2.14. Thank you.